Hello, my name is Lucky and today I am going to talk about the hash function. Why do we need hash function? If we use linked list for the storing and mapping down the data, it is not that efficient because when we need to look up the data in the linked list, we would need to traverse the whole list node by node until the desired data is found. For example, if we are looking for number 11 in the linked list, then we have to traverse and look from 1 to 2, 2 to 3, 3 to 4 until 11 until it is found. And the worst case for the linked list would be ON, which is not very efficient. Hash tables are needed when we need to use or when we need to have speedy insertion, deletion and lookup of the data or element when it is required. So what is a hash function? Basically, hash function can be defined as the function that compresses the input in such a way that output is shorter than input, or in another way we can also say that hash function take in the input, usually the string, and give out the output in the number based format. Input in the hash function is called a key and output of the hash function is called hash value, and value is the data we want to store in the key. And for example, if we use key name as socket, then on using hash function hash socket give out 4. Let's say 4 is the hash value that it will give out. And if we use hash function again on the same key like hash socket, the hash value will not change. That is, it will give a hash value as 4.
Hello, my name is Saket and today I'll talk about hash tables. So a hash table is basically an array-based data structure which is used or created by hash functions to store data. So how are hash functions used to create hash tables, or how do they create hash tables? So as I explained, hash tables are array-based data structures to store data. So let's say we have a table here which has index values. Let's say we just have small 0, 1, 2, 3. But in real life, hash tables are really big. These are just examples. Okay, now we have keys. Let's use keys as build, cat and dog, and their records or the data we are going to store. Let's say build is 12, cat, the data we want to store is 1, and dog we want to store a data of 14. So if we insert build into a hash function and let's say it returns the hash value, some hash value which maps to the index value, index number of 2, so the data 12 will be stored in index 2. And cat, if we use it in a hash function and it maps to the index number of 1, so cat, the data of cat or 1 will be stored in index number 1. And dog, let's say it returns index number 3, so we will gonna store 14 into index number 3. Even though hash functions are faster, but they still have problems, or they face problems. For example, as we use example of build, cat and dog, let's say we have another key which is let's say Richie, and the data we're gonna store is 15. And let's say when we store the data and the index value, when we put Richie into the hash function, it returns an index value of 2. Now we can see that 15 the data of Richie and the data of Build will be in the same array. These are called collisions. These collisions are anything or any data which are in the same array but are of two different keys. To avoid these collisions, there are two common solutions. So the first one is called chain hashing, which we use linked list data structures in storing collisions. So for example, in the previous example, as I said, Richie and Build. So these two will be stored as linked list, as Build being the tail and Richie being the head. And the second one is called open address hashing. In this one, if the index array or the array is stored with a data and a collision is happening, the data will then be changed or moved to the next free array. So in this example, Richie will be moved into index array of 4. So now I'm going to talk about good hash functions. So what are good hash functions, or what are its characteristics? So a good hash function should be easy to compute, and it should have even or uniform distribution, and also it should be able to generate different hash values or more unique ways of the key. Okay, now I'll give you an example of a good hash function. So what if we want to create a hash function of a data for students? Okay, let's say we can use gender, we can use country of origin, and we can use, let's say, grade code. Let's evaluate these three topics and which one would be used for a good hash function. I can say gender will be not, because there will be many males as well as females, so more collisions and it's not evenly distributed. So let's cut that out. And country of origin, there will be some countries with less people, but some countries would have many people, so that is also not a good hash function. But grade code, on the other hand, will be a good hash function, because for each student there is a unique and different ID code. For example, Build, Richie, and Lucky, each of them would have, like, for example, code Build would have 1279, Richie 8321, Lucky, let's say he has 9999. So as you can see, it's easy to compute, it's evenly distributed, and it's able, so each value will generate a unique code for the key.